So we're going to make a small game until everything gets up. Some unexpected challenges. I don't know what happened, but it got stuck, so it's kind of rebooting. It'll take some time. It will connect. Don't worry, we're not going to play any game. But I'll start talking, and then get you bored, and then hopefully, shortly, my laptop will recover from the accident, and I can be back on stage. Okay, so hello everyone. Again, apologize, no slides. I'll be shortly getting on. My name is Ariel Shuper. I'm Senior Director of Product Management in Aqua. Is anyone here in the audience not familiar with Aqua? Oh, after 3 days, we thought to change our name from company to the Liz Rice Company, but if still people are familiar, so Aqua is around good. So Aqua is around microservices security, providing security solution for cloud native workloads, containers, serverless containers, etc., all of that. Peer to Aqua, I work in checkpoint software technologies, a lot of work with firewalls. Wait, everything is connected. Firewalls, intrusion prevention systems, sandboxing in the more larger space, and now in Aqua, working on securing cloud native workloads. Great. Okay, just give me a second. CPU utilization is high. Great. Great. Okay. Okay. Great. Thanks, God. Now all is working. Okay, perfect. So now, why am I excited to talk about sandboxing? Okay, sandboxing in general, and then talk about container sandboxing, because sandboxing, for those who are familiar with the security, the larger security space, was a huge revolution in the security environment. Why is huge revolution? Because all the sophisticated security tools were very reactive, meaning there need to be a vulnerability to discovered, and then only when the vulnerability was discovered, or the exploit, or the worm, only then a fix could be applied, a fix could be made. Now, all the victims of the first discovery, of this zero-day attack, were victims. They suffer. There was no cure for that. And all the security systems were reactive, only reacting to existing threats, more security, etc. Now, this was very frustrating, because you always need to catch up. Now, when sandboxing was first introduced, it was a very nice revolution, because from now on, security systems can be reactive. They can be before. They can discover those zero-day attacks. So how does it happen? Any suspicious file was first emulated. It was tested to see what it's trying to exit, what it's trying to do, to see the different patterns that classical malwares or backdoors take. And then you can reach a conclusion if it's benign or malicious and act accordingly. So in the classical security space, sandboxing was a huge revolution. So when we start hearing customers talking about sandboxing in containers, and we start seeing more technologies evolving around sandboxing containers, we thought, great, now there is a real solution. We can all go retire, say in peace, everything's going to be great. We're going to use sandboxing also for containers. Now, if you look at the timelines of the last year, it was very, very busy. Somewhere in May, Google released gVisor. In July, IBM released Nabla containers. In August was the first GA release 1.0 of Katacontainers. And even 2 weeks ago, during reInvent, those of you who were there, they released Firecracker, which is also another member of this family. So there was a lot of excitement in the past few months around container sandboxing, and we thought it's going to be great. We started digging into it, exploring it, and we found that the reality is a little bit different, and that's what kind of the purpose of my talk. We're going to talk about sandboxing, understand the reality, understand what it's trying to do, what are the best cases to use it. So a quick disclaimer, you're not going to leave this session with a cookbook of how exactly to use it. but hopefully you're going to leave this session with some more knowledge about sandboxing, different considerations, what you can do or you cannot do, and what's the best way to operate with it. Great. So what I'm not going to talk about in this session, I'm not going to talk about security versus performance. Okay, that's a very nice, interesting topic. A lot of work about that. I used to kind of track an Excel file in Google Docs that someone keep putting up information. But last week, Openstack released a very nice study about performance benchmark. I have this reference ended of my presentation, some nice, interesting references. You can find it there. It's really very interesting and thoughtful work on different performance benchmark around containers. Now, if anyone in the audience ever worked with performance benchmark, you know this is the biggest lie in the industry. Why it's the biggest lie? Because always people try to pick the benchmark which their product or solution shine, and their competition, of course, looks the worst. But I must say, when I look at this OpenStack work, was very nice, very detailed. It was trying to be super objective, take a lot of real-life scenarios, real environments. It's not like trying to kind of highlight why Kata container is better. So great work. You're all encouraged to take a look at it. It's very impressive. So this is covering security versus performance. I'm going to talk about a little bit about the operational aspect, but not kind of into the details. Also, I hope I'm not, no one's going to be frustrated. I'm not going to talk about sandboxing exploitation. I'm not going to show you how to break out of the different sandboxing technologies. We explore it, we work it in Aqua. If anyone is interested, is welcome to talk about a little bit more about it, but it's not going to be the purpose of my presentation. I'm going to talk about the actual technology. So it's not a child play. Definitely it's a little complex, not so easy to use. I'm talking about different security aspects of the different sandboxing technologies. And I'm going to talk some operational perspective to see how you can really tie it into a real-life environment, into an environment which contain multiple systems, multiple environments, multiple containers, and what you can do with it. Great. So before digging into the actual technologies and going to the details, you probably want to ask yourself, what are we trying to solve? Okay, what are we trying to do with containers? Why do we really need it, right? And before we go into the technology, understand the solution, let's first understand what's the problem. What are we trying to solve? What are we trying to achieve? So I dig them in like the notable or the interesting attacks that happened in the last year. So I think the first one early in 2018, somewhere around February timeframe, I saw some interesting report from Redlock. They discovered a very interesting attack on Tesla Kubernetes environment. So Tesla Kubernetes console was exposed on the cloud, no password there. So attackers, of course, found something interesting thing without a password. They went in. Interestingly enough, they found AWS credentials, access key, and secret key in this console. And then, of course, they approached the Tesla AWS account. They found an S3 bucket, which was not encrypted. Inside this S3 bucket, there's a lot of juicy information. And from there, it was like a very quick way to install their crypto mining. They did some kind of an interesting or smart crypto mining inside. It was not like utilizing 100% CPU. It was only utilizing a small portion of CPU, so it's hard to discover. They use a network proxy that you cannot detect, like, you know, the known IPs for crypto mining. It was very sophisticated until they were caught and, of course, deleted. A month later, I saw an interesting way how to hack Kubernetes kubelet. So Kubernetes kubelet, the APIs, if you don't mention anything different, the APIs allow any API calls to be made. They don't need authentication. And then, of course, people can use the kubelet in order to create a backdoor and install another crypto mining technology. And even last month, I received an interesting note from Juniper Labs, and they sent me this in the preview to look at it. Interesting report about showing how they can use Docker API in order to propagate and infect all the hosts in the environment with interesting crypto mining. So all those crypto mining, a lot of crypto mining, you hear a lot about it, not pleasant, not nice, not comfortable. You know, might be called to the board, explain why. But it's not, you know, it's not critical, right? It's not pleasant, but not so bad. But then last week, no one prepared us for last week, because last week, those of you who didn't follow the news, there was a huge vulnerability which was discovered with Kubernetes. A researcher, I think in Rancher, found a way to reach privilege escalation and get root access to your entire cluster. And for attackers, privilege escalation, getting root access is the holy grail of any attack. You don't need more than that. You get root access, you can do anything which you want on the cluster. You can take all the credentials, all the secrets, you can destroy, delete, copy, just do whatever you want. And this is something which is really serious. This is not just crypto mining. This is something which is really serious. It's something that no one really wants. So when you're trying to analyze the different attacks, then I think, I'll skip that. What it's easy to see that nothing there is really new, okay? The attack pattern are pretty much the same. What's new is the environment. There are more entities to attack. There are more entities that we can try to attack and we can try to breach, but the methods are the same. They're pretty much the same, port scanning, expose ports, expose APIs, no authentication, no authorization, no passwords, no encryption, all those things that we can really easily avoid, but there are more entities to look at. There's more entities we need to secure, and there's more things we need to take into consideration. Now, when we try to think about how like holistic container security look like, there are different vectors we need to look at. So one vector is how we can minimize the attack surface, okay? We want to minimize how the way or the option attacker has into our environment. So how do we minimize the attack vector? We remove vulnerabilities, we remove sensitive data like credentials, or we can encrypt it. And we're trying to minimize any, create network policy, create authorization, and with a password, do anything that will prevent attacker to reach our environment. The second thing that we will do is we'll try to minimize the attack potential. Okay, now assuming someone managed to attack, now we want to minimize what it can do in our environment. So we'll work in least privileges, we'll require authentication and authorization for every attempt, we'll use role-based access control, we'll encrypt everything. So we'll make sure that even someone managed to break in, then it cannot do too many things to our environment. And last but not least, then if someone already managed to break in past everything, we want to minimize what we call the attack radius. What are the consequent things it can do? What it can access from the environment, what it can reach, what it can do, any additional damage which you can do once you already broke into our environment. And in this context, this is exactly where sandboxing is coming. So sandboxing is taking care of the attack radius. When you're applying sandboxing to your environment, you're making sure that someone managed to break in for some reason, he will not be able to access the host, okay? He will not be able to get into more containers, into the host, into another elements in your environment. So it's important to take it into consideration when we look about containers and sandboxing and understand that sandboxing is a good way, is a good thing to do, take part of our security posture. So now let's dig into more details and get into more understanding about sandboxing. So first, what's the motivation? Okay, so we understand the motivation. We know that unlike different VMs or different entities that we used to work in the past, containers share the same OS, same operating system, they share the same kernel. It's great for the apps team, it's nightmare for security team. Why is it nightmare for security team? Because a zero-day exploit or any type of exploitation allow you to break out the container and reach another, or either the host or additional containers in your environment. Okay, so this is why we need sandboxing. So sandboxing in this case has a two-phase or two-dimension to its operation. On one side, it isolates the container. On the other side, it provides the container anything which it needs from the kernel, right? Because if container will be able to access the kernel, then why do we need a container to begin with? So this is the purpose of containers, of sandboxing. But now you can ask me, why do we need that? Because if I want to isolate my kernel, I already have many options to do so. I can use Seccomp, which is a way to create whitelisting or to whitelist the allowed system calls. So with Seccomp, I can define what are the system calls which allow to the container to use, block anything else, and then I reach the same isolation because theoretically at least I cannot get more from the kernel than what the container actually can do. Another technology is SELinux, which is a nice way to do access access control to your resources. So it's an interesting way. Every process get a resource. Every resource get a role. Every role can access a different part of the allowed part of the kernel. And it's also a nice way to limit what you can do. So a process cannot do more than what you allow him to do. And this is another way to isolate your kernel. And AppArmor is another example, which is quite similar to Seccomp. But the reality of all those tools is that they're not so easy to use or to manage. So the reason why sandboxing is becoming an option, because all those kernel isolation technologies are great, but when you start using them, you see that they're not so easy to use. So for example, I can tell you that we have an experience with Seccomp profile. In Aqua, we allow customers to create an automatic Seccomp whitelisting profile. So we took different containers, we allow for every container created an automatic way to whitelist all the allowed system calls. But in reality, only few customers using it because it's hard to trace if there is any issue. There is a change or modification. How do you modify it? How do you trace it? If there is, it automatically turn off if you're trying to get a system call which was not whitelisted, it automatically will block it. It's very hard to debug it, to find where it is. And if by chance you made a modification to your container, it's going to just kind of fly without even understanding why it happened. So it's quite complex to use. I think SELinux, whoever had experience with it, know it's also the nightmare of any IT organization or DevOps team, and why usually disabled by default. And even AppArmor, which is a more friendly way to whitelist system calls, I found a nice GitHub project of Jeff Frazell doing an AppArmor profile generating called Bane. And if you can read the screen, then you can see why it's called in this nice way, because as Jeff Frazell said, reviewing AppArmor profile pull request is the bane of my existence, right? So you can see it's not so easy to use, not so intuitive, and when you run in a fast environment, multi-container environment, large scale, probably it's not the easy way to use. I can tell you I had an interesting discussion just 2 days ago during the event with one of the big industry giants that has 2,000 engineers, a lot of skilled people, maybe they've even sit in the audience, that have a dedicated team which is responsible for creating Seccomp profile, AppArmor profile. But in reality, when you're a regular enterprise and you're trying to apply it, you have so many other things to do, you probably don't have this skillful team which is only dedicated to create AppArmor profile or a Seccomp profile. And this is why you're looking for something which is more simply easy to use and doesn't require a PhD to get it done. So let's get into more details. Let's take a look from the inside, and let's examine the different technologies. So I think the first one, the most notable one, or the most, I would say, mature one, is Katacontainers. So kudos to the Kata container team. And Kata container took the approach of taking in hardware virtualization. So they create an isolation in the way that took in hardware virtualization technology and optimize it to fit into containers. So every container or every pod is booted as a VM with its own unique kernel with no access to the host kernel, which is great. Because now if I leverage a zero-day attack or leverage any type of backdoor which I install in your Docker image, I can only reach the kernel of this VM. I cannot reach the host kernel, which is great. It's great for isolation. It's an OCI compatible runtime, which is really great and easy to use. All the known commands, very nice. It has an agent inside each VM and a shim outside the VM, so you can intercept all the OCI commands or any IO request and translate it vice versa. So the agent is kind of like the hyper is providing all these calls for the VM, and the shim communicate with the agent, and it's a great way, or at least very nice architecture. Now, let's talk about the security aspects of Kata containers. So Kata containers leverage QEMU as a base for their QEMU light virtualization, which is great. Now, when I look at all the work, and I did a very nice and interesting work on that, all of it was around performance optimization. Really optimize the performance, remove devices, remove things, quicker boot time. but not a lot about security. So security, of course, is a byproduct. If you remove a lot of code, you remove a lot of devices, then you minimize the attack surface. But I was really wondering, what about the security aspects of Kata container? Now, what really became me kind of more, I would say, curious about it is an email which I saw on the email exchange of Katacontainers email list. It's saying, it was pretty much around the release of 1.0, asking, are there any tools or available tests to test the promise in Kata containers? AKA, did we really test the security of this piece? And the answer, the surprising answer was, no, we didn't test it. So I said, okay, maybe I'll try to see it. I'll just kind of make a quick look and take a look at it, because doesn't you know QEMU? No, it's not the best, I would say, technology security practice. So I look at the QEMU, which is the base for the QEMU Lite, and I saw that QEMU in the last year had 10 critical vulnerabilities. Not high, not medium, not low, critical, and it's only in the last year. So you're saying to yourself, whoa, 10 critical, and the last one just a few months ago was fixed. So this is a big potential for vulnerabilities. And you think about it a little bit more, you see that early in 2017, Google removed QEMU in order to harden their virtualization environment. And even a little bit more digger inside, you see that almost any security firm released a vulnerability or discovered a vulnerability in the QEMU, and you're saying, oops, maybe it's not the best security tool, or maybe not the best base for my security. And this is something which, from my perspective, put kind of a note on the usage of QEMU as the base of my of the security level of this isolation. Looking into gVisor. So gVisor, if anybody here attend, Google had a very nice presentation about it 2 days ago. It's a really nice and creative way to limit the user space, to create an user space kernel. Okay, so actually there is very limited access to the host kernel, because any system calls, any attempt the application is doing is intercepted by the Sentry, which is the process that's responsible for this kernel system calls, and it provides any needed resource or support. Any file system access is done is traced by Gopher, so Sentry uses Gopher, and Gopher is kind of a proxy that handle all the system calls all the file system access that the application need. So in this way, they can really isolate the host kernel and really minimize any potential system call access to the host, which is a very nice, they call it SECOMP on steroids. It's very nice. It's really limited attack surface, and it's a great work. So it's creative, it's interesting. And gVisor include an OCI runtime called runsc, which integrates with Docker, with Kubernetes, and make it also very nice to use and a good tool, or easy to use for those who are familiar with Docker and or want to run with Kubernetes. Now, the challenge that we see with gVisor is that Google took an ambitious approach, right? And the ambitious approach is to create a new user space kernel. Now, the kernel for many years was kind of tested, was breached, was patched, was fixed. And when you create your own kernel, you're taking the risk of discovering all those previous old legacy attacks also in your environment. So I think there was no surprise that somewhere end of October, there was even someone from Google who found a way to do kind of breakout and reach the host file system by gVisor. So it was discovered in Google, it was discovered in early October, fixed by the end of October. 2 weeks later, privilege escalation. Another researcher found a way to do privilege escalation and to rewrite files which not belong to the container. And again, I'll expect to find more and more classical kernel attacks applied to the gVisor environment. And this brings us to the other architecture, which is Nabla. So Nabla took a completely unique approach to container sandboxing, okay, and using unikernels, okay, unikernel based on Solo 5, using also something which called ROM-PROM. I never had experience working with it, but allow it to kind of using some more higher level programming languages like Node, Python, and Go, which is really a very nice way to completely minimize the attack surface. Using SECOMP, they allow only 7 system calls to reach the kernel. And just like anyone else, they support an OCI compliant runtime. and provide this ability to use it in a nice way and also very secure. Now, I think it's no surprise that since they're using unikernel and using something which is very, very rarely used, or maybe even not too much used before, I don't know how many people had experience with Oasis operating system or unikernels in the audience, but the rarely it's used, of course, the less attacks you will find. I mean, attackers will not waste time on something which is rarely used, and we didn't find any vulnerability. So on the security aspect, it seemed that Nabla seemed to provide the desired host or kernel protection. Now, interestingly enough, Nabla also created an interesting security benchmark called horizontal attack profile. What is horizontal attack profile? They try to quantify what is the risk of every technology by trying to see how much code each technology creates and how many system calls it allow, and create some kind of a matrix to try to estimate what is the risk of every technology. And I don't know if you can see the screen, but the lower, of course, is the better, and Nabla is the light blue one, which is very low. And I think pretty much, I think it's understood. It could be easily understood. So on the security aspect, they did a great work. We'll talk about operational aspects in a few seconds, and here we'll see it's a bit more challenging. Another alternative, which is relatively new, I must admit we didn't have too much time to play with it. It was just released 2 weeks ago, just before KubeCon. So in last reInvent, AWS released Firecracker. So Firecracker is the new addition to the team. It's an optimized virtualization environment, a lightweight micro VM using KVM, not QEMU, which is a good start. AWS uses it for all their serverless environment, like Lambda, like Fargate, and they're using it for that. And which is it's a good approach, because we know a lot of customers came to us complaining about how do they make sure that no one is kind of attacking them from the host, how can they be secure, they're not sure where the containers or the servers are running. And this is a great way how you address this concern by isolating the instantiation of the container or the function from the underlying host where potentially attackers can hide. So this is a nice way. They optimize it for performance, very short boot time. They also security optimized. They removed all the devices, removed all the things, really left it with a bare minimum, which make them move very quick on one side. On the other side also minimize the attack surface. So if we leverage the previous benchmark, the horizontal attack surface, Firecracker also received a high score. They didn't update the benchmark, so that's why they didn't include it. But when you apply the same methodology, you can see it also receive a fairly low score. Now, they don't support an OCI runtime per se, so it supports containerd, but the way it supports containerd is kind of in an interesting way. They also have a shim that translated the OCI commands into the VMM. They have an agent inside that interacts with those commands. They have another snapshotter, something that allows you to create image in containers. So I'm saying it's an interesting way. It's not like sandboxing per se, like all the other technologies. You can like run any containerd or any kind of a runtime command, but it's a good way. They have a word map, and I'm sure they'll reach it, and it's open source, so everyone can use it. So this leads me to talk about, we didn't test the security way, but talk about some operational aspect. Because if we create great security tools, but those tools are nightmare to operate, then who's going to use them, right? So we need to think about balance between security, but also how easy it is to use those security tools. So when I'm thinking about ease of use, I'm talking about installation. So gVisor was very simple, easy to use. Kudos to the gVisor team if they're in the audience, did a great work. Katacontainer, slightly more complex, but again, nice and easy. And Nabla is also simple and intuitive. Now, if you want to run, those who want to run, the daily operation. So when you look about the support for the OCI, so Rana has Kata container, they have the Kata runtime. Apologize for this cutoff. So they have the nicest runtime, all the different commands, very easy to use. Again, great work. The run SC from Google is also nice and easy to use. Run CS The Nabla one is a little bit more complex. But again, this is not the only challenge there is. Because Nabla comes with a lot of limitation, a lot of challenges. You can only use their base images. Very hard to create your own. You can't use like any base image for container that you have like in Docker Hub. You create only base image with the unikernel. They're very limited. You create your own, but again, the effort required to initiate and start working with it is much more complex. It's much harder. So on the operational side, there's still a lot of improvement that's required on the Nabla side. Another important aspect of sandboxing is performance. Now, why is it important? Because sandboxing obtain a performance penalty. When using a sandbox environment, there is inherent performance penalty, whether it's because using a hypervisor emulation that has an I/O performance penalty, or using a different thing. You're coming up with performance overhead. So whether it's 15% or 20% on the I/Os or on the CPU. CPU, what I saw from all the benchmark are relatively low, but again, there is more CPU required than a classical container. So CPU and memory overhead is still small. Boot time is very quick. You can see in few hundred milliseconds, you can be up and running. And again, this is the source. You can look at the OpenStack. They made a very nice benchmark all different scenarios. Also, when you're using your networking stack in user space, of course, it has performance penalties. So this is why if you have a lot of system call or I/O performance, all this hypervisor-based approach will suffer. So what it means to us is that practically what's going to happen is that sandboxing will be implemented selectively. So it's not going to be implemented all across the environment, but it's going to be implemented only on those ones where you see a bigger risk or higher risk. So if it's going to be implemented selectively, then we need to ask ourselves, okay, so how does it coexist with a regular environment? So how does it coexist with like orchestration layer? How does it coexist with other containers? So the interesting thing that I found that orchestration, of course, is a must. Okay, I don't think you can really run in a real runtime without orchestration, so that's a must. Kata provide the best support for Kubernetes. It's still experimental in gVisor. Nabla, it's among the other challenges. It's also, although they're in November timeframe, they said they support Kubernetes, but the whole runtime is still experimental, right? So it's still, they do support it, but it's still on experimental phase. Now, all the sandboxing runtime, interestingly, can coexist on the same host. So there's no need for exclusivity. You can run all of them, or you can play with all of them on the same host, or put some containers with this one, some containers with other ones. And also, I think very interesting and very important, you can run regular containers and sandbox containers on the same host. So you don't need to run only, it's not either all. You can do some, you can do part, and it's something which makes it very, very easy to use and allow you to apply cautiously sandboxing on where you think it applied the best or where you think it's most required. So now, let's wrap up. So in a nutshell, containers attack are on a rise. I think there is no surprise. The more popular container will be, the more attackers will look after this new environment. Sandboxing is a good method to minimize the attack radius. It will not solve your security concerns. It will not remove all the barriers. It will just minimize the attack radius. We looked at 4 different sandboxing alternatives, 3 architectures, virtualization, user space kernel, unikernels. Unfortunately, personally, I didn't find any knockout alternative. I'm sure there will be some more work. They're going to be involved. We're going to see more and more coming in. But at the moment, there's no knockout alternative in any of those that we tested. Good security for containers required to address attack surface to minimize it, the attack potential, how we can make sure that what an attacker can access or do is very limited, and of course, then address the radius. Now, interestingly, I saw a very nice blog from Jess Frozel, that's saying when you talk about gVisor was released, was just saying the same thing, that if you really want to protect your containers, there's more than one layer of security which is required. And of course, sandboxing is nice. It's a good way. It's improve your security posture, but you still need to take care of other aspects when you want to create, I would say, holistic security for environment. So those are all the resources available in my presentation. Thank you, everyone. And if you would be love to hear your feedback, come to our booth.